All right. So today's lesson's going to be more of a reteaching based off what I've seen for the uh, quiz submission so far, the summatives. It seems that a lot of people were having trouble with the principal angles and or finding coterminal angles. So I'd like to dedicate this for you guys. All right, and we're going to practice on that because it's very important that you're able to do this, and I think I need to be a little more clear about it. All right. So in this problem, I have secant of t is equal to 2 radical 3 over 3. In order to solve these problems, ideally what you want to do is try to get this into terms of either sine or cosine and use that. So the fact that I have secant isn't ideal, so I can just rewrite this. I know that secant is the reciprocal of cosine, so if secant is 1 over cosine, that means that cosine should be 1 over secant. So I'm going to take the reciprocal on both sides right now and turn this into a cosine by doing a reciprocal. That means this turns into 3 over 2 radical 3. But the issue is that based off my knowledge of the unit circle, I've never seen a 3 over 2 radical 3. So having it in this form doesn't help. What does help is rationalizing the denominator and hoping that some way, somehow, that makes things easier for me. So I'm going to go ahead and do that. Multiplying both sides by a radical, multiplying the numerator and the denominator by a radical 3 over 3. Right? That leads me to 3 radical 3 over this and this get me a 3. So 2 times 3, which is just 6. And then 3 divided by 6 is just a half. So this just gets me radical 3 over 2. So this problem in the red is asking me the same question as this problem over here in the yellow, which I'm going to write out just to make it super clear. I'm trying to figure out where cosine of t will equal radical 3 over 2. Okay? So, knowing the unit circle, I know that cosine of t is equal to a radical 3 over 2. That occurs when I have a reference angle of pi over 6. It helps to know it. It also helps to look back at your notes to help you with that. So I know t could be pi over 6, 5 pi over 6, 7 pi over 6, or 11 pi over 6, right? These are all the angles that have between 0 and 2 pi that have a reference angle of pi over 6. However, I want cosine of t to equal a positive radical 3 over 2. So the fact that I want cosine to be positive means that I'm going to combine these answers with my knowledge of the coordinate system. And here's what I mean by that. Right? All students take calculus. That's the one that I grew up with and that I know, but I asked you guys to kind of create your own. So if you're using your own mnemonic device, all right. And if not, well, you have all students take calculus. And this is why it's important. All trig functions are positive in the first quadrant. Sine is positive in the second quadrant. Tangent is positive in the third quadrant. And cosine is positive in the fourth quadrant. So if I want cosine to be a positive value, that's going to occur in either the first, where all of them are positive, or the fourth, where cosine is positive. So that means that these two these two angles that I just highlighted in the red would not work because those are principal angles that are found in the second and third quadrant. Because those are the ones that would give me a negative output for a cosine. So I want to keep pi over 6 because that's from the first quadrant and 11 pi over 6 because that's in the fourth quadrant. Okay? So those are my principal angles. Now, it seems like a lot of you guys are okay with why I'm adding the 2n pi where n is an integer. That makes sense to you? So I could say that t could equal pi over 6 plus 2n pi, or t could equal 11 pi over 6 plus 2n pi. Okay? And so if, like this right here are my general solutions, they include my principal angles. And the principal angles I'm talking about are the solutions that would satisfy the trig problem in the interval of 0 to 2 pi. So those two circled angles are my principal angles. One represents all the angles in the first quadrant that I could find. The other one represents all the angles in the fourth quadrant I could find. So if I'm asked to find coterminal angles, aka angles that would exist within a certain interval, then I just need to add or subtract rotations, aka the 2 and pi kicks in, because that's completing entire loops. So as a result, if I'm doing this by hand, I can think about 2n pi as 12 pi over 6n, where n is just telling me how many rotations I can add. Same here, right? So I can add rotations to make it more and more positive. So I could say this would give me 13 pi over 6. It could give me 25 pi over 6. It could give me 37 pi over 6. Or it could give me 49 pi over 6. And I just can keep going forever and ever. If I want to move in a positive direction. If I want to move in a negative direction, then instead of adding the 12 pi over 6, I can just subtract instead. So if I subtract, pi over 6 minus 12 pi over 6 should give me negative 11 pi over 6. Or it could give me negative 23 pi over 6. Or it could give me negative 35 pi over 6. And I'm not going to keep going because I think you kind of get the gist of it. So all of these angles that are cyan and orange are coterminal angles. So if I'm looking for angles that fall within a specific range, I can just look at these and say, hey, are these greater or less than, I don't know, negative 2 pi or negative 3 pi? How many rotations am I adding to it? And the same idea follows if I'm looking at the second general solution where I have the principal angle of 11 pi over 6. If I keep adding the rotations, well, that would just get me 23 pi over 6, 39 pi over 6, 51 pi over 6. No, I messed up. It should be 35 pi over 6. And it should be 47 pi over 6. I got a little carried away with my adding because we're all human, right? Yeah. And if I subtract rotations, I get negative pi over 6. And I get negative 13 pi over 6. And I get negative 25 pi. over 6. And you kind of get the picture there. So that's how I use the trig ratio in my knowledge of the unit circle to find the principal angles between 0 and 2 pi. And I just keep adding or subtracting 2n pi rotations to find the coterminal angles. And that's all you really had to do for this part. I would say make sure you're more comfortable with the unit circle. Some of you guys are doing awesome with it. And some of us need to maybe make some flashcards or look at Quizlet for the unit circle to help you with this. So tomorrow's assignment is going to be a quizzes where I just ask you to identify coterminal angles and I ask you to identify these principal angles because I need to make sure you're okay with that. And then Monday we'll pick back up with the Pythagorean, with verifying trig identities. Have a good weekend.